Amazing. Good evening, everybody. Thanks for joining for the last day of Rusty Days. We're going to chat for the next 30 minutes or so about observability. In particular, we're going to discuss if the Rust ecosystem at this point in time provides enough tooling to write observable APIs. And we're going to go through the journey of writing one and see how that came along. My name is Luca Palmieri. I work as a lead engineer at TrueLayer. We're going to spend some words about that in a second. In the Rust ecosystem, I contribute to the Rust London user group, where I curate the Code Dojo. I've been contributor and maintainer of a variety of crates in the open source ecosystem, Lympha, Wiremock, and some others. And I'm currently writing Zero to Production, which is a book on Rust backend development, which I publish chapter by chapter on my blog, which you can see linked down there. So let's get to the meat of what we're going to discuss tonight. This is a little bit our agenda. So we're going to see what Donate Direct is. Donate Direct is an application, and it's going to drive our whole journey. We're going to see what it entailed to bring that application to production. And then we're going to zoom in on 3 types of telemetry data, which are often collected to observe the behavior of applications in production environments: metrics, logging, and distributed traces. If you don't know what they are, or you haven't experienced working with that before, that's not a problem. We're going to give all the details, and I'll walk you through why they're useful and how we collect them. So let's start from the very basics. What is Donate Direct? Before that, let's get 2 words on what TrueLayer does, which is going to frame the conversation. Now, TrueLayer is a company which operates in the financial technology space. In particular, we provide APIs for people to consume. We mainly provide 2 types of APIs, one for accessing banking data on behalf of a user, and then one to initiate a banking transfer, once again, on behalf of a user. So you pay using your own bank account, without credit cards, without intermediaries of other type. During the COVID pandemic, as many of the people, we kind of tried to think what we could do in any way to help relieve pressure or contribute to what was happening. So myself, with a group of other colleagues, put together an application called Donate Direct, which lets you use our payment initiation technology to donate money to charities. So as you can see in the GIF on the left, the flow is very simple. So you select a charity from a list, you specify how much amount you want to donate, then you fill in some tax stuff, and you get redirected to the flow of your bank. And the money goes through your bank account to the charity without any fee. So TrueLayer did this completely free of charge, matching some donations. Now, as it happens when you do side projects of different kinds, so things that are a little bit outside the main product line, you have a chance to experiment with technologies which would be considered a little bit too edgy to be used in the core product. And as you might imagine, considering that this is a Rust talk in a Rust conference, Donate Direct backend API is written in Rust. Now, it's not our first round with Rust, but it was our first Rust API in production here at TrueLayer. It was the first time we were actually shipping code that was responding interactively to users coming from the wild web. So I want to see lots of emojis when I rewatch the stream at this specific slide. Now, as I said, we experimented with it before. So we were doing build tooling, we were doing CLIs, we were doing some weird Kubernetes controllers for non-critical stuff, and so on and so forth. But once you actually put an API in front of a user, then the bar of how that API needs to be raised significantly. Which brings us to our journey to production. Now, to use the words of someone that's wiser than myself, one does not simply walk into production for a variety of reasons. And reason number 1 is that, generally speaking, production environments are very complex. So if we look at this diagram, this depicts Monzo's production environment. So each of the blue dots is a microservice in Monzo's cluster. And each of the lines connecting 2 dots are microservices talking to each other over the network. Now, TrueLayer is not Monzo, so it doesn't have 1,600 microservices interacting in production. But you might imagine that our production environment is equally complex in many subtle ways. And what generally you try to plan for in a production environment is not even really the epi case, so is stuff actually working, but you try to predict or to mitigate the way stuff can fail. So what happens if one of those blue dots, for example, in the Monzo cluster goes down? What happens if one of those blue dots start responding more slowly than it generally does or is supposed to do, or it doesn't elastically react to surge in traffic? All these kind of behaviors in a very connected graph like that can cause cascading failures. And it becomes very, very difficult once something like that is happening to troubleshoot why and fix it, if possible. Now, what does each of those blue dots actually is? Now, in TrueLayer's case, we run a Kubernetes cluster. So all our production applications are deployed on top of Kubernetes, which means those blue dots are Kubernetes deployment. Kubernetes deployment is just a service definition, which is going to orchestrate a bunch of copies of the application. Each of those copies is called a pod, and the pod may be composed on one or more Docker containers. The pods are identical to one another, and so they can be dynamically scaled to match traffic increasing, and they can also be on different machines in order to give us redundancy if one of those machines ends up going down for whatever reason. Now, what does it mean to release something to production? Here at TrueLayer, especially when you look at things from an operational perspective, you want to have a certain set of guarantees about what each of those applications provides from an operational point of view. What this means is you want to be sure that the set of best practices is being followed consistently. All those best practices are collected in a huge checklist called the pre-production checklist. Now, if you are an on-call engineer, the pre-production checklist is in many ways a very nice thing, in the sense that it gives you a baseline level of quality, especially on the observability side, as we're going to see. And you can be sure that those metrics and those logs are going to be there. Now, if you're a developer who's trying to deploy a new application, the pre-production checklist can be a significant hurdle, because there are a lot of things that you need to do in order to actually see your application out there. And so, keeping along with the Lord of the Rings metaphor, they might look a little bit like the Ghost of the Rings, and they look quite scary at this point in time. This is like the first movie. So what's the dilemma? On the left, application developer, or in general, like you're building something that looks really cool, you want to ship it. And when you are at the beginning of your startup journey, so when you are a skanky group doing a skanky app that is only built by a bunch of people, we implicitly know that what you're doing is particularly risky, because a new product is a new company, you just iterating fast, it's fine to just ship it. So you put your cowboy hat on and you just deploy to production. Now, as you mature along the journey, you start to get bigger and bigger customers. And those customers will have enterprise expectations. So they want your service to be up. You will have SLAs with them. And in general, just your reputation will demand of you a higher level of reliability. Now, if you're TrueLayer and you work in financial technology, that is even truer, so to speak, or for example, a random consumer app. You don't expect your payments to stop working. They should always be working. And if they don't, that can cause some serious disruption. So software has to be treated as mission critical as much as possible. And to be reliable, there's a lot of bells and whistles that you need to attach to your application. So metrics, tracing, logs, horizontal potato scaling, alerts to know when something goes wrong, network policies to prevent escalations, liveness and readiness probes to tell Kubernetes when to restart something, and so on and so forth. Like the list can get very long. And that is troublesome, because in the end, and that's my personal motto, I would say, is convenience beats correctness. What this means is that if doing the right thing is in any way, shape, or form more complicated than doing the wrong thing, then someone at a certain point in time will find a reason not to do the right thing. They have a deadline next Monday and really need to ship this application. Or they think it's too complex and actually they don't need all that stuff. Like this is a small thing, it's going to run in the cluster, it's not going to get big. Then it gets big, then it fails, and then you have problems. So you want people to fall into the so-called P to success. They should naturally converge to doing the right thing, because doing the right thing is the easiest thing to do. Now, I'm not going to cover all the possible things that we require application to do, because that would be long and potentially quite boring. We're still going to focus on telemetry data. So think in topic with the talk, are we observable yet? What kind of telemetry data? So we said logs that we ship into Elasticsearch, metrics, which are scraped from Prometheus, from our applications, and traces that we push into Jaeger for distributed tracing. So we're going to go one by one, look at what they are, why they're useful, and how you collect them in a Rust application. So let's start from metrics. Why do you want to collect metrics? Well, generally speaking, you want to collect metrics because you want to be able to produce plots that look exactly like this. So you want to be able to see, well, what's the latency of this application in the last 30 minutes? And potentially break it down by percentile. So the 50th percentile, the 70th percentile, the 90th, and the 99th, depending on the type of application, your performance profile. Or you might want to know what's the response breakdown. So how many 200s, how many 500s, how many 400s, and so on and so forth. Metrics, generally speaking, are there to give us an aggregate picture of the system state. So they're there to answer Boolean questions very often about how the system is doing. Is our error rate above or below 10%? Is the error rate for requests that come to this specific API on this endpoint above or below a certain threshold? Are we breaking our SLAs on latency? And metrics are supposed to be as real-time as possible, so they tell you what the system state is now in this very, very moment. What do metrics look like? So how do you actually get those plots that we just saw? Metrics are generally look somewhat like this. So you have a metric name, which in this case is HTTP requests duration seconds bucket. So a bit of a mouthful, but it's very precise. So we're talking about the duration of HTTP requests, and we're looking at a histogram. So we're looking at buckets of requests at different thresholds of latencies. On this metric, we have a set of labels that we can use to slice the metrics value. So we have endpoint, so what endpoint you're hitting. The HTTP method, get, post, put, patch, whatever. The status code we returned, so in this case, 404. And then you have the bucket that we're looking at. So 5 milliseconds, 10 milliseconds, 25, and so on and so forth. And then the number of requests falling inside that bucket. Now, this was a super fast 404, so all 1,601 fell beneath the 5 milliseconds. That generally is going to be a little bit more varied. This is basically a time series with a variety of values you can slice and dice from. These time series are produced by the application and then are aggregated by Prometheus, at least in our specific setup. So Prometheus hits the /metrics endpoint on all the copies of an application. Well, it could be on another endpoint, but that's generally the default. Aggregates all these metrics, indexes them, and then allows you to perform queries against them. One way to perform queries is to do alerts. So Alert Manager, you define a variety of queries which evaluate for Boolean. So as we said before, is the error rate, so the number of 500s, above or below 10% for 15 minutes? If yes, then through PagerDuty, get an on-caller, so an on-call engineer to look at the system because something is wrong. Otherwise, you can use Grafana if you just want to do some pretty visualization. So if we go back to the slide we saw before, which is this one, this is Grafana. So we're looking just at Prometheus queries visualized. This is very, very useful for an on-call team or operation team to actually understand what is going on. Now, how do you actually get metrics? So how do you get your API to produce metrics? DirectRect was developed using ActixWeb for a variety of reasons. I wrote a piece about that a couple of weeks ago, if people are curious. It's very, very easy. So there's a package on crates.io called ActixWeb Prom, so ActixWeb Prometheus. You just plug the middleware inside your application. Is that .wrap prom.clone line. The middleware takes some very, very basic configuration parameters, so a prefix for the metrics and the endpoint you want to use, and then you're set up. You're just going to expose /metrics. Now, you might want to customize it for your specific application because you might need to collect metrics which are non-standards. You might have specific naming conventions and so on and so forth. But ActixWeb Prom is like a single file type of crate. So you can go there, use it as some kind of a blueprint, and adapt it to do whatever you need to do. So metrics, useful, very easy to collect. Just plug and play if you're using Appix. Logging. As we saw, metrics are about what is happening in the system, in the aggregate, at this very, very moment. So low latency, fairly aggregated type of data. Logs are instead useful to answer the question, what is happening to this specific request, such as what happened to users who try to do a payment from, let's say, HSBC to Barclays in the UK between 5 p.m. and 6 p.m. on the 27th of July. There's no way, unless I'm very lucky and the labels on the metrics are exactly the ones I need, but generally they aren't, because labels are supposed to be low cardinality on metrics. There's no way I can generally answer this type of question. Absolutely, I cannot answer it to this single request type of granularity, because those are all aggregated in metrics. Logs, instead, can provide us to that level of drill down that can allow us to slice and dice to get that precise level of information. That is key to actually debug what is going on in a distributed system, especially when things go wrong in a way which you haven't actually accounted for, the so-called unknown unknowns or emergent behavior in distributed systems. So let's look at what it looks like to log in Rust. So classic approach, Rust 1.0 approach to logging is you use the log crate. The log crate is built using a facade pattern. So the log crate provides you a set of macros, debug, trace, info, warn, and error to actually instrument your application. This is an example taken straight from the log crate documentation, or at least I think it was. You enter into the shape, the yak function takes a yak in a mutable reference to yak. You meet a trace level statement. So you announce to the world, we are commencing the yak shaping. It's trace level. So it's at a very verbose logging level. In most cases, it's going to be filtered out. Then you loop and try to acquire a razor. If you get a razor, info level log statement, razor located, display implementation of the razor. You shape the yak and you break from the loop, and then you exit the function. If instead you fail to find the razor, then you emit a warning saying, I was unable to locate the razor, and you're going to retry. Now, facade means that you have no idea what is actually going to consume these log statements. You just instrument your code, and then generally at the entry point of your binary, you are going to introduce a logger implementation. So an actual implementation that takes this log data and then does something with them, where something is generally shipping them some places. If you use the simplest possible logger, which is generally mlogger, you're going to see something like this. So you log into the console, standard out. In this specific execution which I made, you get unable to locate the razor for 3 times. So we're looping 3 times, and then you actually locate the razor. So you have the log message, the name of the function, and then you have a timestamp and the log level. Now, this may work if you're doing command line applications. So if it's a single main function running and you have a user looking at logs to understand what is going on. In a backend system, especially in a distributed backend system, you have applications running on multiple machines. These applications are generally some kind of server, either a web server or a queue consumer or something like that. And they're executing many, many requests concurrently. And you want to be able, at a certain point, generally later, so you're not really there tailing the logs, to say what happened to request XYZ, which was about this type of users, as we discussed before. And the only way you can do that in plain logging is using text search. But text search is not easy to search. First of all, it's expensive. It cannot be indexed, and requires also a lot of knowledge about how the logs are structured. So you end up, if you want to do anything that is non-trivial, so anything which is not, tell me if this substring is in the log, you end up writing regexes. And writing regexes means that you are coupled to the implementation of the logging inside the application, which makes it very, very complicated for operators and support people to actually go and use these logs. So all the pressure of operating the software ends up on the shoulders of the developers, which we want them to be there, but we don't want them to be the only ones who can answer questions about the system. So a much better way is to have structured logs. Structured logs in the sense that to each log line, we associate a context. And that context needs to be searchable, which in a very informal terms means that the context is in some machine-readable format that somebody can parse and index, allowing people to filter on it and perform queries. So let's have a look at how we could do structured logging. So similar example, not fully identical. This time, the debug macro is coming from this log crate. Slog standing for structured logging. Slog crate, this one as well, very established, been there for quite some time. It allows you to specify the log message, so very similarly to what we were doing before, and then allows you to specify using the O macro some key value pairs to be attached to your logs. Now, slog has been for a very long time the only way to do structured logging in Rust. Recently, if I'm not mistaken, the log crate has added a feature to add key value pairs to log statements. But once again, as far as I've seen, at least after a month ago, almost none of the Logger implementations actually supported key value pair logging. So you're once again down to slog for doing structured logging. So what are we trying to do here? What we're trying to do here is what we generally want to do in distributed applications. So I want to know when something is beginning, I want to do some stuff, which might be composed of some subroutines. So this subunit of work function that might emit their own logs. So this event log, so who. And then you want to know when that thing has ended. And then given that we're shaving the yak on behalf of somebody else, so we're taking this user ID, I want the user ID to be associated to every log line. And I also want to capture along the whole application took. So I want to capture that elapsed milliseconds at the bottom. If, once again, we plug into it the most basic type of formatter, so in this case is a Boolean formatter logging to standard out, we get exactly this. So you see all the log statements, you see all the Boolean metadata, and everything is a JSON. So that means that I can parse this as JSONs, and I can filter on user ID very, very fast, very, very easily. Or I can push all these things somewhere else, which is going to index them and search them. And we're going to see that in a few seconds. Now, let's go back to the code. You may agree with me that this is very verbose. It's very, very noisy. Like you have a lot of log statements which are interleaved with the application code. And you don't even see the application code here, but this function is already looking a little bit hairy. And this is because, generally speaking, for most use cases, at least the one I encounter in the wild, having orphan log events is generally the wrong abstraction. You reason about tasks, and tasks have a start time, they do something, and then they end. So what you really want to use as your primary building block when you're doing some kind of instrumentation for structured logging is a span. And a span represents exactly a unit of work done in the system. So let's look at the same function using spans. We are moving away from slog, so we're leaving slog behind for the time being, and we're moving on to the tracing crate. Tracing crate is part of the Tokyo project, and I think it's not an overstatement. It's one of the most impactful crate, at least on what they do on a daily basis, which has been released in the past year or so. Provides extremely quality implementation, and we're going to see it suits our needs perfectly. So a span, we enter into the function and we create a span. Debug level, so we set the level as if we were doing logging. We tell what's the name of the span, yak shave, and we associate with the span the user ID. Now, the tracing crate uses a guard pattern. So when you call the .enter function, then you're going to enter inside the span. Everything that happens between the enter function method invocation and the dropping point of the _enter guard is going to happen in the context of the same span, which means there's no need for us to add, once again, the user ID to debug. And there's also no need for us to do anything weird about subunit work. Subunit work can ignore the fact that it's part of the yakshave function. It can just go on to do its thing. And they will be able to emit log statements. And if those log statements attach context, then we can also capture the context from the parent function. And all of these happens pretty much transparently. What this means is that if we really want to shrink it, So if we really want to go to the essential of it, we can also remove those 2 lines of boilerplate, so that span equal and then the enter function. Just use the tracing instrument proc macro, which is going to basically the sugar exactly to the same thing and leaves us with this function. Now, what's that? That's like 1, 2, 3, 4, 5 lines, considering there's a closing bracket, so 4 or 5, depending on how you count it. If you go and compare that to our slog version of this, you can clearly see how the Gnostic implementation is now much less intrusive. It's, as we were saying before, much more convenient. It's much easier for developers to slap hash tracing instrument on top of a function, and so allow them to build very, very domain-oriented trace spans and do that consistently if that does not involve writing a lot of code, it does not involve polluting their function code, and is generally transparent to the application. Now, tracing, just like log and just like slog, uses a facade pattern. So what you do, you instrument your application using those macros, and then you have subscribers. Subscribers are the ones that actually receive this tracing data and can do something with it. So tracing can be used for structured logging. I think at this point in time is the best crate if you really want to do structured logging. So you can log all those spans to standard out or to a file or whatever you think it's useful to you. At the same time, using spans. And spans are exactly the concept used by distributed tracing, as we'll see in a second. So one type of instrumentation, tracing, and you're able to get, at the same time, writing no extra code, both structured logging and distributed tracing. And this is extremely powerful and also extremely consistent, because you're going to get the same spans across the 2 type of telemetry data. So telemetry data, how do we actually process logs? How do we actually process traces? So logs, we take tracing, then we have a subscriber that prints logs to standard out in Boolean format. Is the tracing Boolean log for Matter, which I wrote for Donate Direct, and it's on crates.io if you want to use it. Then standard out is tailed by Vector. Vector is another Rust log corrector that we use to get logs from standard out to AWS Kinesis, which is then going into Elasticsearch, which we then search using Kibana. So there's a bunch of hops, but in the end, you end up in Kibana. And Kibana is fairly good to search logs, and you don't need to be a developer to search logs in Kibana. So you go there, you have all the possible fields of your logs on the left, and you can filter either existence, non-existence on the specific value, doing regexes if you really need to. You can build views and graphs, and in general, it's very, very friendly. And we use Kibana at all levels inside the company. So from the application developers to the product managers, to the support engineers, to the first level of support, to customer success managers. That's what allows us to own, in a distributed fashion, the operation of a product. Distributed tracing is more or less the same thing, just from a different perspective. So when you talk about logs, it's generally about a single application. So you have this application that is there and is doing stuff and is emitting logs. Now, in a microservice architecture, as the one we have here at Layer and in many places at this point, to serve a single request, which is hitting the edge of your cluster, that request generally flows through 1, 2, 3, 4, 5, 6 different microservices, which cooperate to fulfill the job. Now, when a customer comes to you saying, I tried to do X and it didn't work, you need to understand where exactly the problem is. So you need to be able to trace that request across the different microservices, and it should be easy to do so. The way you do this, or one of the possible ways, is by adhering to the Jaeger tracing format, which is now being evolved, but the Open tracing format, which is now being merged into the Open Telemetry format. So on the tracing crate, you have a tracing Open Telemetry subscriber, which is maintained in the same repository. You can use that, and we do, to ship logs into Jaeger, to ship traces into Jaeger. Jaeger is once again backed by Elasticsearch, so it's more or less the same infrastructure, and allows you to have this kind of view. So each of the units of work appear as a bar. You track how long each of those take, and you can see all the different services that a single request coming from the outside flows through. That is very, very powerful to understand when something went wrong. So you're able to correlate a request across everything that is happening inside the cluster. So one final recap. As we said, production environments are extremely complex. And if you don't have any way to observe what is happening, and that generally means having some kind of telemetry data, then your production environment is a ticking bomb. It might be alive today, but it's going to go off at a certain point in the future, and you're not going to like it. In order to know what is going on, you need to add diagnostic instrumentation. But for that to be there consistently, it is to be easy to add that instrumentation. And make it easy and convenient is your #1 priority as an operator, in general, as an architect of a platform. Now, different type of telemetry data gives us different type of information. So metrics are great to alert and monitor system state, while logs, especially structured logging with high cardinality context, is amazing to try to detect and triage failure modes that you might not have prevented when you designed the system. To get very high quality structured logs, SPAN is generally the type of abstraction that you want to use. And no matter how good your logging is at a single service level, you need to be able to trace a request across the different services. Either you do that with distributed tracing or just a correlation ID that flows through. You need to have that somewhere. And overall, I guess the lesson learned is we were able to get a Rust application in production in less than a couple of weeks with top-notch observability and telemetry data. And that generally means that the answer to the talk, which generally is, if you're doing a talk with a question as a title, the answer is no. Like Steve, the first day, the answer in this case is yes. So are we observable yet? Absolutely. Like tracing has been a step change improvement into the quality of the Rust log ecosystem when it comes to telemetry. And you can definitely ship high quality applications with very, very granular telemetry data. Now, Donate Direct was an experiment in using Rust in a live production application, and we liked it. So in one way or another, probably the CTO was not fully sober when he said that, but we chose to bet on Rust to do some new core projects, in particular writing a core banking application, which in a nutshell means creating accounts programmatically, moving money in and out programmatically once again. We're assembling a team. We hired already a bunch. We're still looking for one Rust backend engineer. So if whatever we covered here sounds interesting to you, just reach out. That's the opening there. That's my Twitter handle. Like, you have many ways to get in touch. And with that, I think this is the end of the talk. And I'd be more than happy to take some questions. Okay, we have one. So let's waffle from Twitch. He's asking, does this telemetry setup integrate well with distributed non-Rust applications? Well, it depends on how what do we mean by integrating well. In our specific use case, we do have some structures that we expect application to follow in the type of telemetry data that they produce. So for example, we expect metrics exposed by APIs to have a certain format or a certain naming convention. We expect our logs to follow the canonical log pattern. So generally, I meet one log line with a lot of high cardinality data that we then use to do a variety of things. So generally speaking, there needs to be a little bit of coordination because, of course, if somebody goes with the .NET Core default format and I go with the Rust default format and you go with the Python default format, it's very unlikely that they're going to really match up really nicely. But you can use architectural decision records to just say, this is how we do logs, and then everybody implements in such a way that they can interoperate. So it needs a little bit of coordination. Okay. So another one from Twitch.Chris is asking, the trace crate looks very powerful. Are there any features that you wish it had? They don't have to be easy features. I'd just like to hear your thoughts on the design space more. Well, yeah, the tracing crate is extremely powerful. I did raise some issues for some of the things that kind of surprised me. So some of those have made their way into the tracing crate itself. Also bug fix on a core dump. That was nasty. But generally speaking, has been amazing. Things that I wish would be different. So at the moment, the tracing crate has a lot of focus on making telemetry fast, or in general, reducing the overhead of doing certain types of operations. For example, one thing is traces. So the metadata you collect about a span is statically determined at the moment of span creation. And that is great because then everything is much faster and consumes less memory. But sometimes, for the way certain applications are architected, you would like to be able to add additional metadata dynamically, even if that means allocating or doing stuff that might not be what you want to do in an auth loop, but maybe for that application and its performance profile works fairly well. Another thing that we found was a little bit of a slippery slope was the instrument macro, which is very, very convenient because it captures the name of the function, but it captures by default all the arguments of the function. And that can somewhat be tricky if you're managing secrets. So if you're managing things that you don't want to log. And so it's very easy to write a function today, put the instrument macro up there, then somebody else comes 2 weeks from now, adds another argument, which is a JWT token, and then a JWT token ends up in Kibana. So it would be nice to have the possibility, or different macros or whatever, to have deny all approach, so that I need to explicitly allow certain fields to be logged, which for the type of application that we do will make us sleep better. But generally speaking, I think it's great. And I think it's going to get more and more useful as different subscribers implementation come into play. So not much to say there. Okay, there's another question coming from YouTube. So Jeff Barszewski, I hope I pronounced that even remotely correctly. How do you configure tracing to send its data to the various backends? Are there docs? Does it also support cloud distributed tracing backends like AWS X-Ray? So there are docs, absolutely. So if you go on the tracing subscriber crate, there are very detailed docs on how to add different subscribers to the tracing pipeline. At the moment, of course, there are some type of tracing subscribers implemented, but I doubt there are tracing subscribers for all the possible things. If in specifically you want to ship tracing data to X-Ray, I think the work that has been done in OpenTelemetry for Rust means that you probably have an implementation of the standard. You might have to write your own subscriber, probably using Rust software that should be not too complicated to actually ship it to X-Ray. But I haven't used it personally, so I don't know if it's out there already. Okay. Once again, from Soulless Waffle, do you have an approach to avoid handling fields that contain personal identifiable information in telemetry data? Well, the approach at this point is trying not to put them there, which, as I said before, so responding to the other question, can sometimes be tricky because of the way instrument works. So generally, we do have a detection system layer to layer. So what we do is we continuously scan the logs with semantic parsers that look for certain types of secrets that we know might possibly end up in logs, like GWT tokens, AWS credentials, and other types of secrets that we don't really want people to have. But at the application level, a parse switching instrument for being allow all to be in denial, we don't have necessarily any specific approach. Okay, here's another question, once again on YouTube, from Jeff. General Rust question, what is your preferred strategy for dealing with error handling? Okay, interesting. In most of the applications we're writing at the moment, we use a combination of this error and anyhow. So we use this error for all the places where we need to handle errors. So it's very nice to get structured enums that you can match on and then do different things depending on the variant. And then when we just want to report errors, so we just want to have something that we log or we return to people as a response, then we use anyhow. And we generally use them in conjunction. So you might have an error enum, which is using this error to get the error implementation. And then the different variants are actually wrapping an anyhow error. And what we're starting to do recently, once again, leveraging the tracing crate, is using tracing error. So capturing span traces in our errors, so that when we get logs, they're actually very detailed about what happened. And that allows us to debug faster. Okay, I guess that means it's all for today in terms of questions. I've been asked by the friends of Rusty Days to pick a winner for a Manning book promo code, I assume. In terms of best questions, that's going to be Soulless Waffle from Twitch. So I think you need to stay online for them to reach out to you. It seems there's one more question, though. Once again, by you, so that doesn't change the winner anyway. What was your thought process for deciding to build this project in Rust? Were there any attributes that made this project a good fit for the first production Rust application at your company? In terms of the application itself, nothing specifically. Like, we're talking of basically a client of an API that we expose publicly is going to power a UI. So it's not necessarily, doesn't need necessarily to be the fastest, doesn't mean necessarily all the guarantees that Rust gives you. So we could have done that in any language. But we were looking to use Rust for other types of projects, so for mission-critical projects, in particular to leverage Rust's very strong type system as combined with this very predictable performance profile. But it's somewhat of a big leap to adopt a new language when writing a new mission-critical project, only to find out when you actually release it that you might have wasted a lot of time. So this was a very nice incremental step to de-risk the technology. So, for example, look at all the observability situations, say, is this actually ready for what we need to do? And look at all the things that we need in an API, and can we actually write APIs with this, and so on and so forth. So it was very much the risk operation. And as we de-risked all of these aspects, then it became possible for us to say, okay, now we can confidently bet on it for this other new product that we want to do. And there's a huge project, and that fits Rust's profile for a variety of reasons. And now we know we're not risking too much. We're still taking some risk, but it's not as big of a risk of passing from a small CLI to mission critical product as they do. Okay, it's goodbye time. So thanks a lot for tuning in for Rusty Days, and stay for the next talk from Dick McManara on unsafe code. Have a good evening. Bye-bye.
Hello, good morning, good evening, good afternoon. I'm speaking to you from before dawn in New Zealand, and I am absolutely delighted to be part of Rusty Days. I think it's fantastic that we've been able to take, or the Rust Warsaw team has been able to take what has been quite a negative pandemic and turn it into a global event, which is perfect. I should begin. So just to reiterate, I'm sure this will come through on the stream. I'm more than happy to take questions via either any channel, via Twitch or YouTube, or I think there's a third channel also. And just ask questions online, and I will try to answer them as we go. The team is actually sitting behind me, monitoring all of those streams, so that's great. Okay, where should we go? We'll start with moving something. Why is my screen not? There we are. Introduction. Who am I? I tweet about Rust on TimClicks. I spend a whole bunch of time wasting time about Rust on Reddit. I do live coding on Twitch. I make videos on YouTube. I write books. So I've actually written this thing called Rust in Action. One of the reasons why I do that is that I've kind of taken it upon myself to shorten everyone's learning journey by 100 hours. Now, if you have just decided to come to this talk because you want to know how to apply unsafe to your own project, I've decided to just give you the answer. We'll give you the answer straight away, so you don't have to watch a whole hour of talking. Firstly, at the top of your crate, add an annotation, which is deny unsafe code. This will, as we'll demonstrate in some other projects, this will prevent the compiler from allowing you to use unsafe unless you have been very, very explicit and opted in. The other one is that before or within an unsafe block, you need to explain why it is that this code is safe. The compiler is no longer working for you, and so you need to do the work of the compiler for any future Rust programmer, including yourself, who might come along and wonder, why on earth is this safe? And so one way which I would recommend when you're doing the code review is to ask them, do you understand, can you explain to me why that is safe? And if they cannot, then either the code needs to change or the comment needs to change. Our objective as Rust programmers, or one of the objectives, let's say, or the objective right now is safety. And let's all remember, while we're going through this process, that other people make mistakes, right? We never make mistakes, but other people do. So how do we prevent their mistakes from infecting our code? We need to create a system of software engineering that makes it extremely hard for stressed, overworked, and maybe distracted individuals to do the wrong thing. We need to create the system as team leads, as engineering managers, as junior developers. We need to participate in a way that learns our objections. So we want to learn about how other projects are managing risk. But first, I would really like to take the time to talk about lemons and limes. Now, if you speak English as a second language, this may sound very strange, but this is the story about how the British Navy, or Britain in particular, understood in the 18th century how to cure scurvy. And by the 20th century, they had completely forgot it. In fact, the scientific advice at the start of the 20th century was so bad that it caused scurvy in the Antarctic and expeditions, quite famously, and led to some horrendous tragedy. And so there were many reasons why this occurred. And one of the main reasons, though, is that a contributing factor was that the English word lime included lemons also at the time in which the scientific, and at the time at which the cure was found, which was just drink lemon juice. Sprinkle some lemon into water and just drink that. And so I want to reiterate that if your code comments cannot be understood by your audience, then they need to change. And it isn't the surface, it isn't the words themselves that are important, it's the meaning behind that. People who are reading your code need to understand why it is that the code that you have written is safe. You need to do the work of the compiler for it. Just a warning. This allowing unsafe is actually insufficient to guarantee safety. Unfortunately, Rust still has some problem. Well, no, it doesn't have problems. It just has something to be aware of. It is actually possible to generate code that is guaranteed to crash your program using only safe code. Now, this is a ridiculous code example. No one is ever going to wrap a vector of type T with another container, but maybe you're doing something stupid. I say stupid. Maybe you're doing something and you don't realize that you've created the situation where two of your primitive types, maybe inside a struct, actually are an invariant on the other one. So that is the position, this position variable here relies on the fact, like, there's an intimate relationship between storage and position that the compiler cannot guarantee. And so by mistake, in this case it's intentional, but potentially, let's say by mistake I've written some code that breaks the link between two of the primitive types. In this case, I can set position to something that is unreachable, and then when the next call, like if someone calls get, this will break and it will crash the entire program. Now, obviously, I could have, there are ways to get around this. I could have replaced this index notation with the get method, and that would return an option. But this is completely safe code, and it is 100% guaranteed to crash. So just before we get to the project, I also thought I should explain a little bit around my methodology, if there was any methodology. I firstly wanted to talk a little bit about the rationale about why I did this. I was really disappointed with the Rust community's response to the AtXWeb unsafe, like basically driving. If you've been around the Rust community a little bit, you'll be familiar with this. But if you're very new, one very famous example of unsafe, or the use of unsafe code, or was this project called AtXWeb, where the developer happily used unsafe blocks. And then when people said, look, you can't do this, it's, there's no requirement, eventually that person was driven out of the Rust community, now because of this kind of cultural difference. And that made me think, like, well, what is the right way to do this? If that is the wrong way, I think it was unfair to drive that person away. And the two main aims, I think, are to understand what it is that professional companies, people that are paid lots of money to write very good software and doing very hard things with Rust, like, what do they do? And I would also like to, I just wanted to do some research to justify doing more research. Actually, I've got several ideas about how to extend this. So what did I do? Sorry, just to pause slightly, doing qualitative research, not quantitative. What that means is I'm not looking for, I haven't hacked the compiler to be able to do an analysis. And this is quite, I've used a lot of interpretation here. So it's not an analysis of every Rust crate. It's kind of looking very closely at 10. And they were basically a sample of products or projects that I thought were interesting. I tried to create a sample of open source from the GNOME project all the way through to like Amazon and Microsoft, these big companies as well. And I was looking primarily at their documentation for new contributors And then I would go in to look at their code snippets via searching for unsafe inside their repository. Now, I intentionally did not communicate with any of these projects because that I was doing this. So none of these projects are aware that actually they have been part of this this project. So let's have a look. Servo. Servo is Rust's foundational project. It was kind of the reason why it was created, to create a parallel web browser. It's fascinating looking through the GitHub because a lot of their documentation around how to write code is written in about 2013. So it's quite old from Rust's point of view. One thing I found fascinating is that they include this annotation of their crates, which is, the annotation that they use is deny, but at the start of any function that uses unsafe within it, they or any module that requires unsafe, they are required to allow it and opt in. So this, I think, is a really nice strategy for increasing the psychological barrier to including unsafe. Now, just to provide this is again another convoluted example, but this is a demonstration of what happens inside Servo. So you can imagine that they have modules, and the module itself has this annotation that we deny unsafe. The deny attribute allows programmers to later on annotate internal things with allow. So you can basically, you're opting out of unsafe here, but you can opt back in if you really need it. The reason why I think this is quite an interesting strategy is that I just feel like it's harder to, and it's harder to do mentally, and there's no way it would pass code review. I think unsafe it's unlikely to pass code review, but this ugly annotation syntax, there's no way that would get through. I was also curious as to what Cargo Geiger does internally as well. So Cargo Geiger is a cargo extension which actually inspects your own code and all of the code of your dependencies for usages of unsafe. But how do they do it themselves? Like this, for me, was really, really interesting. They've gone further than deny unsafe. They've actually said forbid. Now, the forbid keyword or the forbid attribute does not allow you to annotate internal methods as allow unsafe. So it just tells the compiler that it's completely illegal. Future programmers in the project will only be able to include unsafe blocks if somehow the project decides to remove this annotation from the root of their crate. So effectively, the way this looks in code is we add forbid, and then it's impossible to the only way to compile this dangerous function is by commenting it out. We cannot opt in to allow. It will not. The compiler will refuse to compile the code. Again, kind of looking into some of Rust's ecosystem. Well, some of the long-standing utilities, I wanted to kind of get a sense as to whether or not the cultural. I wanted to know if the unsafe usage had changed. So Exa is a replacement for the ls command, which is a Unix utility, and it's one of the Rust community's oldest command line utilities that is in public use. So Exa talks to a file system, and it does that via system calls. It doesn't need many. It does not use much unsafe at all, but for extended attributes inside, it requires this the list extra attribute SYCL family on Linux and Mac OS. So the strategy that they have developed is to only wrap the minimum of what they need. So basically every single function that they wish to call, now I'll explain the syntax very quickly in just a moment, but effectively this is the Rust code. And all they are doing is wrapping the C function. And so the strategy there is to put unsafe around the smallest element possible. And the idea is, I assume, to make it very, very understandable about what is the purpose of unsafe. And in this case, we are, the reason why we need unsafe is because the Rust compiler cannot reason about what happens inside the operating system. And so it just requires you, we just need to expect that the operating system is going to be well behaved. Now, going back to that comment around, we need to understand why this is safe. If you haven't used pointer syntax, this is probably confusing. I want to, so first of all, we have a whole bunch of types that are not really used in traditional Rust code. But if you're using libc, if you're using any FFI, you've probably seen that before. And if you've programmed in C, this probably makes some sense. We take a path, so a pointer to effectively, in Rust syntax, this would be a vec of U8. We've got a reference to C string. A C string is like a vec of U8 with a null byte at the end. And then we're creating a null pointer, which in the convention of C programmers is to spend a null pointer, kind of how a Rust programmer would use an option, 0. I'm not sure what that does. So that is, I think, size. And we have an integer being used as flags. And the way that works is that in C, a convention is that each bit represents an on-off switch, and so that's what that's going to be used. So bear in mind, it's important to think about whether or not your team is familiar with this kind of code. If it is, maybe it doesn't need comments. But if it is, like if you have team members, or you might have new team members that are less familiar with this type of syntax, be verbose. So this is where it came from. Another example that I think is quite interesting is Blake3. So Blake3 is this new cryptographic hash function that's supposed to be really, really fast and also very good. Oh, I think I've just received oh no, I haven't received a comment. Oh, by the way, if you're watching this live, do ask questions. More than happy to receive them as we're going through. You have stopped using MD5. Just asking that question, right? It's no longer best practice. So why is unsafe needed in this project? Well, Blake3 wants to make use of very high performance functionality within the CPU, and that requires intrinsics, access to intrinsics. We have vector instructions that can operate on more than one element at a time. So they have used the minimal wrapper strategy as well. Now, this is a kind of like a vector. Well, actually, it's closer to an array that has a width of 256 bits of integers, and we call this kind of crazy thing in the middle. This is what the unsafe. This is the function that's provided by. And if you've used, making no sense. This is the function that is provided by the compiler when you opt into intrinsics. And from the Rust code, we only see add. A lot of the complexity is hidden from us, and I think this is a really interesting strategy. Now, one thing that the authors of the crate have decided to spend extra attention on is that when we use pointers in unsafe blocks, that's especially dangerous, and we need to be especially careful. And so they've made extra effort to annotate those sections with code comments. Now, I get into a project from Amazon, and this is the foundation for the AWS Lambda and the AWS Fargate projects. And so this first we'll start with the question like, why do they need unsafe? Well, they're interacting with a hypervisor. They're basically building an operating system manager. And they also use a lot of Chrome OS inside their own project. And so they've actually got a lot of code generation. And so their strategy, and I don't mean to blame them. It was just, I thought, they've just got like, it's automatic code that includes unsafe. And so there's just this comment there saying that this is automatically generated. And so that's their strategy for a lot of their users. Just a comment saying, I don't know why this is safe. So, I wanted to call out their contributing Markdown file. Sorry, it hasn't rendered very nicely on the screen. The point I want to make here is that they have a big document which explains why you should or how to contribute, but it doesn't address unsafe at all. It talks about code comments and so forth, and pull requests and unit tests, and that's all great, but this is an operating system project, and they don't mention unsafe in any of their guidelines. Microsoft is developing a language prediction, otherwise known as a Rust interface for the Windows runtime, which I think is ridiculously exciting. Like, it's amazing to see that Rust's usage across operating systems is first class. So thanks to Microsoft. Obviously, they speak to Windows APIs, whether or not that is like kernel 32, DLL, or whichever interface that they use. They need to trust the operating system, and so they have to use unsafe. So their strategy, again, are these minimal wrappers, done slightly differently. So this is a bit of a confusing method to see. What we're dealing with here is an array of type T, which happens to be generated by the Windows runtime. So it allows you to create. So what we're trying to do in this impl block is create methods that allow you to create objects that the Windows runtime understands. Now, there are several other methods as well, but I want to call out with len because I thought this is where we have unsafe. And so so this is we're creating a new object here. So this is kind of like the with capacity, only it's or vec with capacity, but here we're creating an array with a length of guaranteed to be, let's say, 1024 or something. We want to make sure first there's this assertion, which is good practice, and then we're saying that this code task memalloc is the call that we need to use, which is fine. But I am personally, if you are a Windows, like a Microsoft programmer, you probably understand what this means like innately. But it feels like to me, as someone who's looking at the code fresh, that this unsafe block is doing quite a lot of work inside it. And so what we're doing is we are calling this part of the Windows API. And we've got our length, so that's the number of elements in our array. And then we multiply that by the size of memory of our type. And so, you can kind of see why that's one function. And then this returns something, and then we coerce it to a pointer to T. So maybe if you are familiar with systems programming, this comes very naturally to you. But I think that if something were to happen inside of one of my projects, I would have expected that I would have provided some explanation about what is happening. But again, maybe if you are developing systems programming, like if you're developing operating systems, this stuff is so natural that you don't need to. I'm not sure. I do know as well that they provide annotations as to describe why it is that the operation is safe. And so we're actually writing to the pointer to starting at 0, I assume. So this is a point data as a pointer. So we just created it there. I assume we start at 0 and we write length. I'm wondering, and I don't know enough about this, but I assume the difference, interestingly, we got length multiplied by system, like this, but here I'm using ling, and I wonder whether or not that's a bug. I'm not sure. I'd be interested to hear from anyone. Can I enlarge the code? Yes, I can. Hi, README Markdown. So what I really like is the Microsoft team believes that they want to create this runtime with 100% pure safe Rust, but they make this call out that sometimes that they have to go and talk to their to the APIs, and they are implemented in C++. And they make safety as like a first-class citizen in their README, which I think is a really positive sign. Now, a project from the GNOME project, a project within GNOME, is they're rewriting libSV, I think lib, a C library in Rust. So this is a CSV renderer. And the question becomes, why do they need unsafe? Well, this crate, lib rust rsvg, SVG, talks to glib. Glib is a kind of a core of GNOME in some sense, and it is like another C library. So again, you can see this pattern of requiring, we're building out new functionality in Rust, and we need to rely on older implementations, or not older, but pre-existing code that is written in unsafe languages. And also Rust itself, the Rust code itself exposes the same C API as the library that preceded it. One thing that I think is really positive in this project is that the entire culture is focused on questioning whether or not unsafe is a valid thing to do. Now, this is a code comment from one of their code reviews inside a merge request, which is GitLab's version of pull requests. And, you know, the project lead there makes this really good point, which is, why are you using an unsafe construct? Because I think that we could use a safer option instead. Now, I found this inside their code after like looking through their commits, and I think it's really positive to see that people have got in their heads this idea that when we can avoid unsafe, we should do so. Because the compiler does not get tired. The compiler does not get distracted. And the compiler can have bugs. I'm sure that there are compiler bugs, but safe Rust is good Rust. We've seen the minimal wrappers strategy before, so I'll just pass on that one. I also wanted to look at the Rust standard library. They have provided explicit advice for code reviews. They require comments around each use of unsafe, and they have some tooling, a lint in their continuous integration builds that checks that there is a comment. Obviously, the lint probably can't read code comments to check that they relate to the code block, but at least they're there. And there are humans checking these things as well. So I like this the last sentence there. Unsafe code actually needs to be okay. Like, don't put unsafe code in there that is actually unsafe. Like, that is not a good thing to put inside the standard library. Another thing that they call out inside their guidelines is that it's okay to ask for help. So if you, we see a mention here of the unsafe code guidelines working group, and I'll mention what that is very, very soon properly. But there are experts inside the Rust language that know a lot about Rust. And so if you are unsure, it's okay to ask them for help. In fact, they've made this point that everyone loves debating whether or not there is an unsound problem here, like whether or not. So, don't be worried. You're actually making someone's day by by being able to get some reasoning here and some expertise. Now, if you are a tiny project, this obviously does not apply as equally to you. So, we don't have a large team of collaborators and colleagues to call upon. And so my advice there would be to be cautious and to kind of build yourself up into things that you know rather than things that you don't. And don't try to use constructs that you don't understand, is what I'm saying there. One thing I think is really, really, really good is that the public documentation explains why things may panic. And if you read the code comments of standard pointer read, you'll see that there is invariants that are described, which is that the source of where you're reading from must be valid for reads. And by the way, you must initialize that value before you actually try and read from a pointer. And so without those, the method is unsafe. And so even if size t has size 0, the pointer must be non-null, which is interesting. But so I think that including, if you have an unsafe method or unsafe function, including a safety section is a very sound strategy. A further project which is less well known is this thing called Toolshed. Toolshed is a memory allocator. It uses an arena strategy, or provides an arena for you, which is basically, to the operating system, it looks like you've just asked for a large chunk of memory. And inside your program, you can divide that up internally however you want. It's typically faster, but can be slightly less efficient. You might get some wasted space. Now, why do they need unsafe? Well, if you're dealing with memory blocks, you probably need to deal with pointers, and that means that you need unsafe. And so their strategy has been to push every usage of unsafe into one specific module, which happens to be arena.rs. Even though the API is completely safe, all of the unsafety is isolated inside one module. And so people know if they're touching that module, like, it's dangerous. And again, like, we're trying to create a situation where, as a team, we are building safe software, and mentally we're switched on when we go and interact with that module. So again, here is another project which is far less well known, which I think is really interesting. There's a new database or a new graph database actually being developed out of Ireland, and inside it, the storage engine is written in Rust, but the reasoning engine is written in Prolog. Now, they need unsafe because they're interfacing with this Prolog implementation. And now, how have they done that? They have gone further than isolating at the module boundary in some sense. They have actually created a third crate. So they have which provides the sort of a wrapper and interface as it completely outside of their project or their core storage project. So the storage engine, written in Rust, that deals with keeping data and persisting it to disk, has no knowledge of the Prolog implementation. It's completely independent, and so if there was a problem with inside that kind of wrapper crate, it wouldn't infect the storage engine. They also have a very strong strategy, like a very strong code commenting practice within inside the team. And so almost seen on the slide, it's a bit difficult. So allow me to explain what's happening here. So inside their code, when they store data to disk or unsigned integers to disk, they compress it using a variable length encoding scheme. There's a public method in CodeVec that allocates memory. So we create a vector of size length, and then we call an internal method, really, which is encode unchecked. Even at this wrapper, this isn't really unsafe. We're just calling an unsafe function or an unsafe method. There's already a safety block saying, we know that we have created our vec with the required length, and so therefore it is safe. And inside that unchecked method, the encode unchecked, there's even more commenting. So this is the internal method. Basically, everything that happens inside this method is well indexed. Possibly, we don't necessarily need to say that about incrementing. But what I think that this project gets right is that they want to assume that people are looking at this code with very, very blurry, tired eyes. And they're even specifying why we're using an integer, sorry, an index integer, which I think I've never seen before. And this makes it very, very difficult to not be, it makes it very difficult, it makes it very easy to understand what the code is doing and very hard to get it wrong, in my opinion. Okay. We're coming up to one of the final projects that I want to touch on, and this is Fuchsia from Google. So the Fuchsia kernel is actually written, it's not written in Rust. Rust is used in kind of systems components, but the kernel, I believe, is written in C++, but might be pure C. Their team, they have got code documentation that makes it very clear that if you're adding unsafe to the code, you need to ensure that it's safe. It's your responsibility. And it's essential that you identify any assumptions that are required by every unsafe block. You need to ensure that those assumptions are actually met, not just that you've identified them, but actually, in this case, that they've been met. And over time, it's possible for those assumptions to continue to be met. Now, this is a really interesting bullet point to add, because it means that the programmer today is responsible for thinking about how people might use this in the future. And this becomes even more explicit soon. Oh, right, sorry, I just added the twice. Oh, well. Yeah, we'll carry on. So one of the things that is very clear by now is that projects that do this well, use unsafe properly, I said properly, add comments to the unsafe blocks to explain why it is safe. And if you're inside the Fuchsia project, you also require a comment explaining, what assumptions are being made. Like previously, we saw that we made an assumption that the length being provided to a pointer read or pointer write was of sufficient length. And so that seems relatively clear. But this documentation is actually available in public for every contributor to the project. Sorry about the rendering of this slide. Where possible, so this is a very good explanation for the minimal wrappers strategy. So where possible, package any unsafety into a single functional module, and then document what it is that needs to be the case before it becomes safe, how things fail, and how things, what happens if everything succeeds. Now this seems like a very, very sound strategy to me. The Fuchsia OS project has the most robust guidelines, in my opinion, for writing unsafe blocks of code safely. Partially for this reason. I apologize for how this is rendered on the screen. So there's a couple of sections here. So there are 3 particular types that the documentation calls out as being particularly dangerous: star const, star mut, or unsafe cell. So these are pointer types. They are specifically called out as things that need to be very heavily documented. And the comment down the bottom is talking about memory aliasing, and that you can either, in Rust, you can either alias, so that means you can have two references. It's got read-only references, so this is the ampersand syntax. You can have multiple of those, you can have multiple readers, but you can only have a single writer. And you need to explain that if you have been able to, if you've used one of these unsafe types, that you have upheld that guarantee that is provided by the Rust compiler. Obviously. So now these resources, you can't click on the links, sadly, but you can definitely look them up, and I will ensure that links are provided for anyone that would like them. And just thinking about the way to get them there. But I'd like to call out the Fuchsia OS team, Brian Anderson. Ralph Jung has provided 2 fantastic articles. In particular, was the person who created that example of having 2 types that are both safe in of themselves, but when they relate to each other and you break that connection, you can create unsafety inside Safe Rust. There's a really nice guide of Rust patterns inside the Rust unofficial repository that talks about condensing or containing or isolating unsafety within small modules. Or and lastly, the Unsafe Working Groups Unsafe Code Guidelines reference, which I would like to see if I can bring up now. So where are we? So inside the Rustlang org is a unsafe code guidelines repository, and you may notice this this author, Ralph Jung, is the same person who wrote those 2 fantastic articles about unsafety in Rust. Now, this is a very good description of the things that you need to be aware of if you are writing unsafe code, and you want to be able to, it isn't quite as mature as I expected it to be, but I think it is developing. And if this is an area that you're interested in, I believe that you should continue to, I think you should participate. So it's the main output of the group is a reference document, and I'm sure that there are many patches welcome from anyone inside the community. And so that is, I think that is the talk. Actually, we'll. I'm more than happy to answer any questions that people have. But just a moment again to say thank you very much for the organizers of the conference. I am very privileged to be part of it, even from the other side of the world. And so I am more than happy to stay online and again, answer any questions that come through. I'll try to get I'll get a link. I'll try to post that in the YouTube comments to where I have the slides and so forth. Yeah, ask away. And any of the channels that you're if you're watching the stream, ask in the comments, and those comments are being monitored. I'm just sending the organizers a link and of the slides that I have, as well as the research that I've done on all the projects, because there's a little bit of more material there that you might be interested in. So we've received our first question, which I think is a really fascinating one, and it's from YouTube, and I believe it's I'm going to get my English pronunciation is going to be terrible of this name. Zignabu Sikaris. What would be your advice to new Rust programmers who are too happy to use unsafe? So so the question there is, you have someone who is new to Rust. Maybe they have a lot of experience, or they've just graduated from university, and they look at unsafe and they say, oh, using unsafe just means I can apply the same idioms that I am used to in C++. Or in some other language. And my advice would be that the reason is to ask them to step back and say, well, why are you learning Rust? You can use pointers manually in other languages, and in fact, in a way that is much more ergonomic. Rust makes it very fussy. It's not nice to use unsafe, use pointers in Rust. I think it's done intentionally. It's intentionally clumsy in some sense. And if you have come to Rust because you want to write in a safe programming language without a garbage collector, then use the compiler to your advantage. There is a second question from YouTube. Again, I apologize for my my English pronunciation, especially the stress on the wrong part of the word. But Michael Lazowski, great lecture, thank you. Which strategy is the best in your opinion? I am not an expert in this. I would defer to the Unsafe Working Group. But if you were going to ask me for my advice, it would be to add a comment to each use of unsafe. And that will force you to mentally check. It will just slow you down and cause you to pause to double check that what you are doing is sensible. That would be my one takeaway. From Twitch, Hashidon, you've covered calling unsafe code inside functions, but what about creating functions which are themselves safe? Do I have any thoughts on that? I do, and that is, I could potentially try and scroll all the way through. So where was I? I was over here. Oh. So I think it was Exa has created a function, like a Rust function, around a C function. Oh, actually, it's a safe function around an unsafe function. Actually, that wasn't quite what I want to do. I believe, oh, no, that's not right either. So my strategy for this is to write minimal wrappers around and create functions that are very, very easy to understand. Okay, another question from Twitch. Chris, please. Thanks for the talk. You mentioned some lints that we can use to assist developers in maintaining code while unsafe. Are there any changes to the language or any unexisting lints that you would like to see introduced to make this easier and more reliable? I would say to that, use Clippy, right? So, let's see if we can find it. Rust Clippy. Not in that repository. Come on, GitHub. Let's do this properly. Okay, there we go. There's Rust Clippy. Now, Rust Clippy is a community repository of good practices. Hundreds and hundreds of these things. And I love this code that is just wrong. Do not use this in your own thing. So now I expect that the lint, that this code comment linting that is applied by, I think it was the one of the projects anyway. I think it was the standard library. I assume that they have upstreamed the lint into Clippy. This is where I would go, and if they haven't, well, you know, there's a job for this weekend. Now, oh, this is great. Again, from Twitch. MRO WQA, why do you laugh so much? I love it. I laugh because I'm nervous, partially. I laugh because I try to remember that programming is primarily creative endeavor. And it's okay to learn. It's okay to make mistakes. It's okay to grow. And that means that we need to do we need to learn in a way that is supportive. And so there's no sense in I don't want to start telling people or dictate exactly how people should code in there, and I don't want people to feel as if they are inadequate in any way. One of the reasons that I program in Rust and took the time to learn Rust, and one of the reasons why I teach Rust, is that it empowers everyone to write strong, safe software. Even me, like I am a mediocre programmer in many senses. Yes, I developed in Python for a long, long time, and probably over a decade, and spent a long time in data science. Every piece of documentation that I wrote, that I read around writing C extensions to make Python go faster, was the first paragraph almost said, only experts should do this, or this is dangerous, or what, some sort of language like that. And I was always intimidated. Rust was the first systems programming language community that made me feel welcome. And I want other people to feel welcome as well. It doesn't matter where you come from. It doesn't matter whether or not you're from the San Francisco, from the Bay Area, or whether you are from South Asia. You should feel like a participant, and you have a place at this table. And I want everyone to feel welcome. Okay, a question from YouTube, from Andrew Bogus. If my unsafe code is unsound but works, for example, it might be faster, should I change it for a slower, but something that is guaranteed, a slower version that is guaranteed to be sound? We have an example of this in the standard library, or not so much. So it probably is the case that if you have something that is fast but dangerous, that it works for known good cases. Like if you set everything up correctly, it will go fine. But if things are set up badly, they might blow up and explode on you. I do not recommend anything that takes user input, or anything you're going to install on someone else's computer. I do not recommend that you expose them to security vulnerabilities caused by buffer overruns. But If you're the kind of person that likes to play dangerous, here's my advice for you. Create 2 methods. The first one, and the one that you should use primarily, is safe code. It is pure Rust. That is pure safe Rust. Secondly, have another method that has the same signature, but has underscore unchecked or underscore unsafe. And describe why it is that when you call this, that, like, what you've done to ensure that it's safe when you call it. If you know that certain edge cases will cause it to explode, call the safe method. Like, if you might be in a situation where they might occur, but if you have initialized, or if you're doing scientific computing, for example, you know all of your data pretty intimately, you know exactly how it's laid out in memory and so forth, you can probably guarantee that the edge cases will never occur. I'm not smart enough for that, so I would urge you to stick with safe. But if you want to, you know, like, yeah, then that's over to you. Okay. Another question from YouTube. Zoran Lazarevich. Have you ever had situations where your unsafe code has broke the safety in Rust? And if so, can you give an example of how that has manifest? No, I have not. I haven't broken the Rust compiler. I know that some other people have. For example, I believe there was a regression in 145 relating to the use of there was a strange edge case relating to propagation of constants, like in like toy code with references, and I haven't experienced that myself. Okay, so YouTube, Michel Lazowski, is it possible to have in your project too many comments? That slide with Terminus DB had quite a lot, in my opinion. I agree. I mean, it's very, very difficult to know where the balance is. Perhaps the balance exists. It depends on the maturity of the project. I can imagine that if you know that there are very competent developers and people who are very familiar with the domain, that you don't need many comments. But if unsafe is a warning to you, like there are some people, they see unsafe, they're like, wow, hey, like this is my play area. Like I love this stuff. I love pointers. It's all fine to me. Then maybe they don't need comments. But if you're the kind of project that uses unsafe in less than 1% of their code base, like probably most projects, and whenever someone sees unsafe, they kind of tense up slightly because they're worried that they're going to crash their own system or potentially introduce security vulnerabilities for their users. Add more comments. I don't know if every single line needs to be commented. I thought it was interesting to find a code in production. At least it provides more robustness. Oh, okay. From Twitch, Soulless Waffle. Is that like somehow reflective back on me? The username is Soulless Waffle. I really enjoyed your talk, thanks. But I have one question. What would be some good starting points for developers who are new to lower level programming language, who want to learn how to safely write unsafe Rust? Do you know of any resources that teach these skills from a Rust perspective? Soulless Waffle, do I have a book for you? I feel very I don't do this because it's an ad. I apologize if this offends anybody. But I do think that my book is designed to do that exactly. And so I think it's appropriate here. The Rust in Action book teaches you both Rust and systems programming at the same time. It does that. It will introduce you to unsafe. It doesn't go through all of those explanations, but it does make you familiar with some of the reasons why you might use unsafe. And so hopefully that's not too much of an advert, but I would recommend in taking a look and checking the reviews and checking whether or not this seems like something that might be sensible for you. YouTube from Andrew Bogus. By the way, ask me if you want a lint and Clippy. I think I want a lint and Clippy. I think the community would love more robustness around unsafe code. And so I spent a little bit of time, in fact, probably too much time, should have been preparing for the talk, inspecting Clippy. And I originally wanted to run linters over every public crate in Crates.io and maybe some, and try and find out whether or not I wanted to go and inspect the uses of unsafe to see, like, what are people doing? Are they manipulating pointers? Are they doing some weird things like transmutation, like interpreting the bit patterns of like various, like an array as integers and so forth. But no. Oh, we've actually got quite a few. Oh, two more comments. I would. And so yeah. Sorry, to answer that question. Yes. Add the lint. I'm sure that Logic, the maintainer of that project, will be happy to accept it. Twitch, Lewis Code. Does Rust have a way of marking unsafe code and working smoothly with it, like Haskell's IO monad? Maybe an unsafe trait marker. That is the unsafe trait. Sorry, that's the unsafe keyword itself, I would say. You're not going. There are people who probably are type theorists and who understand Rust's type system very innately. But I'm just going to admit some ignorance there. I think that you could possibly have marker traits. You could definitely create something that's like, you could create a marker trait which implies unsafe, I believe. Yes, and I'm just thinking off the top of my head. I've never done it, but I think that there are unsafe traits. And so as soon as you implement that, you mark your own type as unsafe. But I'm going to express a little bit of ignorance there and just allow the type theorists in the back channel ask on Reddit, ask on users.rustlang.org and find out, because again, participating in the Rust community is exactly why Rust is great. These technical reasons are fine and perfect. You can see that other language communities are adopting a lot of the D is investigating lifetimes, and C++ have changed their practices to be able to use smart pointers rather than raw pointers, for example. And so the technical parts of the Rust community, I think, will be adopted by other languages. What we have that's special is the participation in the community aspect. And so if there's something that's unfamiliar to you, I would strongly encourage you to ask. Now, Michael Ward on YouTube asks a question: why do you feel like bad about promoting my book? I'm 8 chapters in and it's great. Okay. I feel bad about promoting my book because people have to pay money for my book. I've been working in I've been contributing open source code for like 15 years, or something like this. And I just find it very difficult to ask for money from people. And I think especially from people who are learning and who don't know what is good and what is not. I don't like, about 90% of people that read my book think it's excellent. No, about 80% think it's excellent. About 10 to 15% think it's very good, and about 5% want to throw it in the bin and throw it in the fire. So now I don't want to recommend that you should buy it if you're going to throw it in the fire. And so yeah, I don't. I don't know. It's just a personal thing. I should get better at asking for money. I'm going to give like an extra 10 to 15 seconds for me to make a decision on the most interesting question. The most interesting question actually receives a. I think Manning, my publisher, has provided some codes to the organizers. If you are selected, so if you think of anything, ask a question. Ask a question. I'll try and include it. But I'll try and pick a winner. If you are the winner, please stay on whichever channel you have asked your question on, such that the organizers can contact you to send you the code. If you are interested, if you are interested in buying the book, if you go to rustinaction.com, there's a 40% discount code on that page. Now, I actually really liked the first question. What would be my advice to Rust programmers who are too happy to use unsafe? I think that this is very interesting from like a psychological point of view, because it talks to the culture of people that are new to Rust and there's a lot to this idea that bringing people to a new there are multiple mental shifts that happen when you learn the Rust programming language. And one of them is this idea that you need to trust the compiler. The compiler is not your enemy. Your compiler is actually your ally. The Rust compiler actually is on your team. And so, I find that, it's not, so I definitely think that one, that for me is the most interesting or kind of the most compelling question. I think it's the one that if I were to have a beer with you all after the conference, because, we're going to the pub afterwards, right? That's the question I think I would spend a lot of time trying to flesh out and explain and understand. So that is the winning question for me. Again, if I would just like to thank the organizers based in Poland for organizing this worldwide event. I think it is fantastic, and I have been delighted with it's been fantastic presenting to you all. So thank you so much. But first, I've just got one more announcement, and that is, I think that there is a hackathon. If I go to rustydays.org and I look for a hackathon link. Sorry, my internet has decided that it wants to go very slowly. Here we are. The topic for this year's hackathon is emergent phenomena, or perhaps if you prefer, can you amaze us with simple rules? Let's create an amazing result with a simple rule set. If you've ever heard about cellular automata, fractals, or similar constructs, this is what we're kind of talking about. So allow me to do one more plug. Actually, if you would like to learn about writing a fractal in Rust, go to my YouTube channel. I have a video which describes how to generate the Mandelbrot set in Rust, and that can be possibly a good. And I've got some other generative art tutorials in there as well. And so, in particular, this one is about creating some generative art in Rust, and we kind of work through a tutorial. So I would encourage you again, to look at my YouTube channel. So that is youtube.com/timclicks. And great. I encourage you to participate in the hackathon. It's going to be fantastic. And have a lovely week. Oh, a lovely weekend and a lovely evening. And I'll see you at the pub because it's the last talk of the conference, right? I'll see everyone later. Take care.